Hi, y'all. We're excited to have you here and want to welcome you to Flatiron School's Intro to Cybersecurity, Coding Demystified using Python. My name is Corey Mickelson, and I am the Marketing Events Coordinator here for Flatiron School. A big part of my job is hosting free introductory workshops like this evening's event to give you all the opportunity to meet some of our instructors and get more of a feel of what the Flatiron School experience is all about. I also host another series called Tech in 20, where we take 20 minutes to discuss hot topics within the tech industry. So a quick little reminder, we're going to be using the chat as our main source of communication tonight. So make sure to set that little blue button from panelists and host to everyone so we can all chat together. So without further ado, I'd like to introduce our host for the evening, Joseph Gowitz. He is one of our lead cybersecurity instructors. Take it away, Joseph.
Thanks, Corey. Thanks everybody for joining us tonight. And it looks like a nice crowd. So I know we've got people from all over the place. If you have questions, please post them to the chat throughout. We're planning on talking for about 60 minutes or more. Yeah, love Python. All right, absolutely. And let's just dive on in. My name again is Joseph Gallowitz. I'm in Rochester, New York, which is near Buffalo and Toronto. And aside from my position here at Flatiron School, I am a professor of cybersecurity at the Rochester Institute of Technology here. And I'm also a licensed attorney in New York State with deep interest in privacy and security and all those sorts of issues, which is what led me to teach here because all that stuff is so central to what all of us are interested in doing. So what we're going to do tonight is sort of both high level and low level. We want you to get to know our program a little bit. We want to, hopefully have you walk away with some knowledge about Python. And the nice thing about Python is that it's very, very, very DIY friendly. You can get off the ground on your own without a whole lot of work. And one of the things that I've realized and done is that with my students is that I boil things down to the barest essence, because I've noticed in the past that a lot of students think that programming is rocket science, and it flies rockets, and that's all good. But actually, at its heart, the core concepts really boil down to 10 basic ideas, and I actually try to cover those about 10 minutes. To kind of sort of prove the point that if you're at all nervous about programming or IT or any of that stuff, I encourage you to take a second look, because by the end of tonight, you'll been exposed to all the programming concepts you'll ever run into. The fact of the matter, that sounds like a boast, but it's actually true. And then you just build on top of that. So that's kind of where we start. But so the preview of what we're doing tonight is that we're going to talk about our cybersecurity program in general. Just want to sort of cover the skill areas that we talk about, and then focus down on cybersecurity, and then on Python itself and where it sort of fits and why it's important, and the things that you can do with Python in cyber. And then we're going to get into like I said, the 10 building blocks of coding, and then finally show you a free piece of software that you can download and a treasure trove of information about Python, and show you a little bit of coding to kind of get your feet wet. And from there on, hopefully, whether you join us or not, you'll get the bug and you can start off on yourself. So Aria, I'm not sure about the name there, Aria Friedman. I have the same background as CPO with a great interest in data science and a lawyer. Nice. Okay, great to have you on board. Awesome. All right, so I'm going to share my screen here, and we'll get going. Okay. Now, our cybersecurity program is, one of several areas that Flatiron provides boot camp style learning in, and it's been greatly successful. And it boils down to 8 different topic areas that we present in 8 different courses throughout. In the full-time live version, for example, 15 weeks in 5 different phases. And what that boils down to is governance and risk and compliance, threat intelligence, applied cryptography, network security, system security, application security, logging and detection of threats and intrusions, and then finally Python scripting and programming. So I want to cover each of those just to give you an idea of what cyber really looks like if you were to sign up, because it's not just Python and it's not just using software. It's actually a lot of bigger ideas. And so it sort of starts with governance, risk, and compliance. This is not the sort of stuff that you see in your favorite movie, your favorite hacker movie, watching The Matrix or anything like that. But this is the stuff that really brings it all together. And the reason that we do cyber is that governance, risk, and compliance is all about hooking an organization into the cybersecurity systems that are available in order to keep enterprises safe and running, or to recover when something goes bad, or minimize it if it does. We try to measure risk, and we try to make sure that we're legally compliant and compliant with policies and frameworks. So that's what governance, risk, and compliance really does. There's actually a lot of people involved in that do not necessarily always have their hands on keyboards and eyes on glass. Middle managers, chief information security officers, and the like, attorneys, law enforcement officials, and that sort of thing. A lot of time and a lot of energy gets spent on what we call GRC. So our GRC course addresses a whole range of topics that are central to securing an enterprise or any sort of organization. And when I use the term enterprise, that's sort of a term of art that we use to describe pretty much any collection of people trying to do something. So that could be, for example, a small business, just a corner store, for example, or a professional office, or a hospital, or a police station, or a nonprofit, or it could be a global enterprise like Microsoft or Amazon. Every enterprise is different, has to be handled differently because of its unique situation in the economy and in the technology, in terms of its budget, and so forth. So understanding how to best address the needs of an enterprise is really important, and that's what we focus on it. And so that includes making plans, writing policies, understanding the different roles of people in an enterprise and what they do, understanding how to measure security issues and risks, what standards are out there that help us understand how to best secure our enterprise. What laws and regulations do we have to follow in order to be properly compliant with the law? And also there's physical security and business continuity. When a disaster happens, you want to make sure that a business can bounce back, and a cyber is a big part of that. Okay. Threat intelligence is the second topic, and the idea here is that we focus on using tools to understand what threats are out there before anything happens in order to erect the correct defenses within the enterprise that we happen to be in. So you can't really defend against everything, and so focusing on the things that matter to you leads us to make hopefully effective decisions that forestall or prevent, or at least minimize attacks if they do happen. We get into cryptography. If you've been doing any banking, or even when you use your smartphone, and you might use, for example, your thumb to unlock your phone, you're using cryptography. And cryptography is the special branch of mathematics that is all about codes and encryption, keeping things secret so that when they're transmitted, it's nearly impossible to crack and get at any sort of secrets you're trying to transmit. Everything from passwords to your social security number to your photographs, your emails, or any of that sort of stuff. As you know, you've probably been on a web browser, and depending on the browser you use, usually if you're staying on the sort of legit side of the internet, you'll be on websites that will display a lock or some other little icon next to the URL so that you know, okay, that's a relatively safe place because there's a certificate that vouches for its security. Not everything is bulletproof, but that's what cryptography is all about in this particular context. If you were taking cryptography on a college level course, you would get into calculus and discrete math and that sort of thing, very esoteric stuff. Ours is more practical because it's the theory stuff is for the mathematicians, but we basically apply everything that they talk about. So what we do is basically teach the ideas of asymmetric and symmetric public key cryptography. We also go into the history of what's happened with cryptographic attacks so that you understand kind of where we've been, where we are, and where we're going, because all of this stuff is forever evolving. The next topic is network security. And that encompasses pretty much everything. And as you see, there's a bit of an alphabet soup here on my slide. And these are just the basic network protocols. Now I'm not going to read them off, just for a few, but everything from, blue wire Ethernet that we're probably all familiar with to the Wi-Fi that we all hook up, at home and at work and at the coffee shop and that sort of stuff, and a whole variety of other protocols that move information around the internet. All that stuff with data constantly moving in motion is exposed to the world and exposed to attacks and has to be properly secured. So network security is its own sort of part. Well, what are we doing with data to keep it secure when it's in transit from computer to computer, from hub to hub, from server to computer, and that sort of stuff. System security is sort of a broader concept that focuses on the overall architecture of a particular network. That includes the operating systems involved, that includes countermeasures that are installed, that includes malware and exploits that are specific to certain environments and that sort of thing. So that is sort of the big picture of all the pieces that get put together that we focus on. Application security is what happens on your actual box, your actual computer, or nowadays pretty much anything, because whether you think of Microsoft Word as an application or you think of your banking app as an application, it's all software one way or the other, and there's applications all around us. If you've got a smart fridge, for example, nowadays, or a smart TV, your phone, your tablet, your car. There are applications pretty much everywhere. And every place there's a piece of software, there is a potential for a breach. And so that is a place that we really need to make sure is always secure. And the way we do that is with an exercise and a discipline called pen testing or penetration testing. A lot of folks in cyber specialize in the idea of using software to explore networks and to try to breach applications in order to find weaknesses that then get fixed. What we try to do essentially is do that, what we call white hat hacking, to find weaknesses before the bad guys essentially do. We use a tool called Metasploit and another package of tools called Kali, which is a specific flavor of Linux that basically is sort of the state-of-the-art toolbox for cybersecurity people. And with all those tools in hand, you can do all sorts of stuff, like mount attacks on systems in order to see what happens when you have the permission to do so, in order to see if there's a vulnerability that needs to get plugged. You can use those tools to deliver payloads in safe environments so that you can see what happens. The nice thing about being in cybersecurity, or I think the interesting thing about being in cybersecurity is that for those of us who are lifelong nerds, and I count myself as one of those, you get to do some really interesting stuff in relatively safe environments with cutting edge software and cutting edge techniques that we try to apply. Logs and detection, that may not sound incredibly interesting, but it's actually incredibly important. All of the systems that we use, and if you think about it for a second, if you were to sit down and write down all the places that you log into on a regular basis, say in a given week or a given month, your email accounts, your bank, your school accounts, your work accounts, and all the different pieces of personal information that get stored in all those different places. We sort of get used to the idea that all this stuff is out there if we're ever really conscious of it. But once you really think about it, every one of us is deeply connected in thousands of different ways. And it's those connections actually that we need to learn how to examine and explore in order to detect problems. That's where logging comes in. So whenever you, for example, log into your bank, there's a record of that somewhere. Whenever you log into your email, there's a record of that somewhere. Pretty much anything that happens out there, there's a trail. And depending on the system, depending on how things are set up, things are constantly being logged. Masses and masses and masses of data, terabytes upon terabytes of data is being recorded, as we speak all the time. And the problem with that is no one person or no even team of people can easily dive into these logs and make sense out of them. And that's where software and Python actually come in, because and bigger systems that Python is based on that we'll get into. But so we want to make sure that we collect these logs, and then we use software to go in and find specific things that we know to look for, or anomalous things that indicate that there's a problem or a breach or that sort of thing. So detection is huge, logging is huge. There are people who specialize in just combing through mounds of data in order to find evidence of malware breaches.
Looks like we have a couple questions in the chat. One about the differences between penetration testing, vulnerability testing, and dynamic and static code scanning. And then another about logging and the differences between IOCs and IOAs.
Okay. That's pretty deep stuff. Let me see. I'm going to stop sharing so I can see exactly what was written. Hang on. So, okay. So yeah, the first question was speaking of the differences between pen testing, vulnerability testing, and dynamic and static code scanning. So good question. Excellent question. So pen testing and vulnerability testing, pen testing is those two terms are almost synonymous. There's not a whole lot of daylight between them. Penetration testing is literally looking for open ports on a network or on a device that can be exploited and, as it says, penetrated. Once you penetrate a system, you can probably do a lot of damage inside, or do a lot of spying that nobody knows about without doing any damage. So vulnerability and penetration testing are pretty much the same thing. Dynamic and static code scanning, and I'm trying to boil this down as quickly as possible because these are really big, deep terms, is the idea that, say you have a sample of code, you find a piece of software sitting on your server or some system that you know is not supposed to be there, that apparently is doing something, and then you need to figure out what that is. So static code scanning is the part of software reverse engineering that basically looks at the code itself. And this is where we sort of knowing basics of programming gets involved. Now, honestly, reverse engineering code is really a very high level skill for people who are deeply, deeply steeped in computer science and computer programming. But it is possible, essentially, to reverse engineer code, because usually it's compiled code that you can't easily read, reverse engineer it into code that you can actually take a look at and read through, and without running it, because the problem is, malware is kind of like a virus. We use that term virus, but in terms of malware. But when I'm using it here, think of the COVID virus or the flu virus or the cold virus, those sorts of things in biology. If you have a sample, you don't necessarily want to reproduce that sample, because if you let it out into the wild, bad things could happen. If you have same thing with a suspected piece of malware that might be a virus or some other form of malware, you don't just want to say, okay, let's run it on a computer and see what happens, because bad things can happen. It could reproduce itself and send itself out into the world and do all sorts of things. And so by reverse engineering code and looking at the code itself, what you're doing is just trying to get an idea of, okay, if we were to run this, what would happen? Dynamic analysis is the idea that, yes, you do go off and run the software and see what happens, but that is almost exclusively done in a sandboxed or air-gapped system, meaning a system that is not connected to the rest of the network, or it's a very limited network that is not connected to the broader internet, so that these viruses and other software can't replicate and send themselves out into the world. So that's just generally the idea. You run software in one case to see what it does, and you reverse engineer software in the other case to see what it might do. As where logging is concerned, you address the differences between indicators of compromise and indicators of attack. So IOCs and IOAs, indicators of compromise, indicators of attack. So there are two different concepts there. They're very, very closely related. So yeah, in logging and detection, we use software systems to comb through massive databases of logged information. We look for indicators of compromise and indicators of attack. The difference is obviously in the last word. Compromise simply means the idea that we can have detected that someone got in. They didn't necessarily do anything that we can detect, but they were there. There's any number of ways to detect that happens, depending on the system and depending on any number of other conditions. And so, for example, think about the idea that if you left your front door open and went and no one else was home, and you left your door unlocked, and you went off about your day for several hours and then came home. If somebody comes into your house, you might not know that they were ever there if all they did was walk in, look around, leave, and close the door. But what happens if they walk in and you notice that, for example, there's a couple of footprints on the rug? You go, oh, okay, they were there, but you don't see that there's anything missing. That would be an indicator of compromise. Somebody was there, didn't do much, looked around, hard to tell what they actually did, why they were there, but they were there. There's a lot of hacking that happens that's simply for people's own curiosity, to just see if they can do it, to just see if they can get into systems. But again, just because somebody didn't take anything out of your house, you don't want them walking around. Nobody wants that. So you want to lock your door. That's similar to making sure ports are closed and that sort of thing, so that there are no indicators of compromise. Then indicators of attack is the next step forward. Okay, they came in and they took your stuff, or they broke your stuff, or they stole your information, that sort of thing, where you actually know that something was exfiltrated, as we say, from the environment that we're talking about. Good questions. Anything else? Wireshark and Splunk, two different things, Ronald. So Wireshark is sort of ubiquitous software that everybody uses in cyber. For anyone that's never heard of it, what Wireshark is, basically it allows you to, what we call sniff a network and record all traffic that is coming and going on a given network or subnet, so that then you can, again, analyze it. In a lot of ways, Wireshark operates like a big tape recorder or other recorder that just gathers data, really doesn't gather the data, gathers metadata, data about data, and then allows us to go look at, for example, the IP addresses and the hardware addresses of data moving back and forth on a network. Splunk, on the other hand, is what's called a SIM, a piece of software that allows us to go through logs and find information from the patterns and evidence that are in those particular logs. Just checking to see if there's any questions before we move on. Okay, good. Okay, and before we broke off to take some questions, I was just getting to the eighth topic in our program, Python. Now, again, we use Python, and Python has become a very ubiquitous language for a variety of different reasons, mostly because it's open source and it is very easy to learn compared to older generations of programs. Now, there's plenty of code out there that's not written in Python. So just because we use Python to teach the basics of programming and scripting, so that you can then build on that in the actual employment situation you might find yourself in later. So by, again, the programming concepts I'm going to introduce you to here in a second are pretty much universal. They're just applied differently with different languages. So there are other languages out there, for example, like PHP or Java, C++, C#, COBOL is still plenty out there. There's lots and lots of other languages. Python is pretty ubiquitous, though, because, again, it's easy to learn and has lots and lots of utilities specific to cybersecurity. Now, again, there's a difference also between scripting and programming. What happens with a lot of cyber projects, a lot of investigations and things, is that there's a lot of repetitive work. And so being able to, what we call script, use basic programming knowledge to create a script that takes repetitive work and makes it a lot easier for us, that happens all the time, is a very valuable skill. Programming is sort of the next step up from scripting, usually more complex projects, more extensive projects, and that sort of thing. The nice thing, what I think is really interesting about cyber, is that there's so much possibility of getting into any number of things once you're out of the program. Because, again, if you go through those 8 different topics, any one of those things can be a specialty. Any one, and a lot of those things, overlap. So while going through our program, you're going to often find that you gravitate to something that's particularly interesting to you. And then hopefully you gravitate to that, and you can make a career out of it. Now, again, once you're done with those 8 topics and the 8 courses over the course of a standard 15-week session, and again, we have longer sessions and other opportunities that if a 15-week program doesn't make sense for you, please look at the other ones. every one of the programs, though, ends in what we call a capstone project experience. And that is a large project where we have a simulated network, a set of problems to solve, a set of issues to find evidence of, and you work as a group, a small group, to essentially work as a cybersecurity team. Hopefully, in the first about 13 weeks of the program, you'll have absorbed enough information so that we then cut you loose and aim you at a virtual network environment, and then basically ask you to act like a cybersecurity team and report back. It's always interesting to me when I see the very last day of the program where the group, each group stands up in front of a panel of us instructors and presents their findings on the project. And what we do then is question and dive into and explore how deeply and how correctly they did what they did. Excuse me. So it's always a fun day. Just a couple months or so ago, we did one of these live in Colorado Springs. It was an all-day event. Everybody had about an hour to present their project after working on it for a couple of weeks. And it really just brings everything together, and it just shows, crystallizes how far people come in, less than 4 months. So, and I think people always really enjoy the projects too. So again, the title of our particular presentation here is, demystifying Python itself. So let's dive into that some more. So why is Python important? It's a great first language to learn simply because it's easy. Its code elements are very easy to understand in plain English. We're going to take a look at some snippets and kind of show you why that makes sense. If you're not exposed to older programming languages, it may not make a whole lot of sense, but just sort of trust me. The uptake on Python is the barriers to entry are much lower than they ever were with anything before, and that's why it's proliferated. It's open source. Those of you who know what open source means, it's the idea that it's essentially crowdsourced resource that people have been working on for well over 25 years now. Python was started by one particular programming professional back in the early 1990s with the idea of creating a language that was easier for people to get into. And he and thousands of other people have succeeded very successfully with that. On top of being open source, there's a ton of free learning resources. I'm going to show you one of those later, essentially the Python home at python.org. And there's just endless amounts of information there and elsewhere to dive into and learn from. Current employers in the current economy, I'm sure if you're here, you're probably interested in some of the many jobs that are out there, or at least exploring the possibilities. Employers love that people know Python. Why? Because everybody's using Python. And so having those skills, at least the foundation, is very beneficial to employers. For all those reasons, people that are already in the field can get up to speed very quickly, or people that are just starting out get up to speed very quickly. There are many code libraries available, both that you can get for free or that you pay for to do specific things. And because of that, there's oftentimes you don't need to reinvent the wheel if you have a particular type of project or something you want to try to do. And essentially, Python can be used for nearly anything in cybersecurity. Again, it does pretty much everything you'd possibly want it to do, but other languages do too. I think it's important that before you walk away from this, we're focusing on Python as the vehicle for teaching about coding. These concepts apply everywhere. So, but Python is the thing at this point. And to kind of drive that point home, I have a list here of how many, I think 7 different, household name type apps and companies that whose websites and back-end applications are either completely or mostly built on Python. That includes Netflix, Google, YouTube, Instagram, Uber, Spotify, and Instacart. All those different businesses do all sorts of different things. And I'm sorry about my dog. Hang on. Hang on. Oh boy. Don't know why that's happening. Just a second.
Thank you, everybody, for sharing your LinkedIn handles. We will be back in just a moment.
Sorry about that. All right. And that's just a sampling. We could go on and find all sorts of other examples, large and small. But the point of kind of what I'm on about here tonight is that at the very, very base of all of these, somebody sat down before there was a Google, Sergey Brin and his partner, whose name escapes me, and they said, hey, we should catalog the internet, which was a pretty revolutionary idea back in the 90s. There were lots of people trying to do that in lots of different ways. Obviously, Google came up to take over the world, but it had to start somewhere. Somewhere they wrote a line of code, and it just built on top of that. And whether that was Python, I kind of doubt it at that point because it was 20-something years ago. But the point is that the concepts are exactly the same. And it's just really repeated over and over and over again. Lots of very simple ideas that build to very, very complex things. So here, the thing I think is I try to do with my students is to sensitize you that it's not the language, it's the idea, it's the expression. So if you think about a programming language, think about that language, just like English or any other language that we speak, the words that we speak or we write, they're just in service to something else. Very few things are done for their own sake. So if you write an essay, or you write a letter to someone, or you write a book, whatever you write in English or any other language is really sort of a form of programming. You are transmitting data to someone using language. Same thing with computer languages. Okay, we're using a basic set of rules, we call syntax, same thing in spoken and written languages, that allow us to use programming elements in order to achieve something. But usually when you sit down and program, you have some goal in mind, something you're trying to do, something you're trying to build to help you do a particular job, just like you would with any other written or spoken language. So some just 8 different general ideas of things you can do with Python and cyber. You can create intrusion detection and prevention systems. If you've ever heard of a firewall is a very simple idea of an intrusion prevention systems. There are much more complicated and host-based and network-based systems now that both detect intrusions to networks and systems and also prevent them, depending. You can analyze traffic in the network, back to Wireshark and other tools like that. You can simulate attacks. You can scan network ports to see what's open and what's vulnerable. You can do what we call system fingerprinting, meaning that it's good to actually, in order, again, back to indicators of compromise and indicators of attack, if you can fingerprint a system at a specific point in time and record that, and perhaps do that on a regular basis, you can tell when things have changed. Those of you who are familiar with Windows, for example, and have been under the hood in Windows and understand what the registry is, I'm not going to get into too much detail about that right now, but essentially Windows, and actually every OS, has a registry. And what that is essentially a big table of all the possible settings and the current system state for the machine. So when you turn on your Mac, you turn on your Samsung Galaxy, you turn on your PC, that loads up and tells the computer the configuration that you want it to be in. If you, for example, load a new piece of software, that fingerprint will change. If you do some web surfing, that fingerprint will change. If a new user is entered into the system, the fingerprint will change. So that's a very, very, very important tool, and allows us to catch changes that we didn't know were going to happen or didn't want to happen. Okay. Website cloning and wireless network scanning and reverse engineering of captive malware. I touched a little bit on that. And it goes on and on and on. There's lots and lots of great writing out there on the internet about all of these things and more. And if you're at all interested, you can definitely get out there and find much more information on this and the other applications out there. So now let's talk about the building blocks of coding. Well, like I said, 10 basics of programming in 10 minutes. And we'll see how we can do this in 10 minutes. Sometimes I go off on tangents, but usually it's about 10 minutes. So, but a little bit of history, just so we're all on the same page. What is coding? It's simply a set of instructions based on simple concepts that together express ideas and solve problems. That's what computing and coding really, really is. And we've all seen ones and zeros out there, right? The idea of bits of information, switches turned on and off, and one setting at one particular place in a computer's memory may not mean much, but you combine them into the trillions, and all of a sudden you've got beautiful photographs or streaming music, or a letter you wrote for whatever purpose. That's all the ones and zeros that encode both the data and the software that works on data that we work with. So it's just this idea of ones and zeros, and that's essentially what a computer understands. Okay, in computer's memory, there's just almost endless list of ones and zeros. Depending on how they're set up, you get different results. So that's what we're trying to achieve here. So now what the language allows us to do is to manipulate the computer. Computers are dumb. They don't know anything. They're just a machine. And they only operate as well as the instructions given to them. Okay. So the particular challenge of computer programming is really driving the machine to do what you want it to do towards the goal you want to achieve. And that's why Python has become so popular, because it really has lowered the barrier to entry to any one of us who wants to dive into programming, either on a casual basis or as a serious vocation. I know plenty of people who have very little formal education, not much past high school, that are amazing and well-paid programmers because of just how they think and how they understand the language. So believe it or not, a workable computer is made up of exactly three features or concepts. Okay, British computer science pioneer Alan Turing in the 1930s essentially defined what a computer was before it could be built, about 10 years before they could be built. Basically, you could do anything with a logic machine if it had three things. Variables, that means being able to read and write information to some sort of storage medium. Logic, being able to simply compare two values to each other in order to make decisions. And then looping, going over data, two or more instances of information in order to perform the same or similar actions on them. Those are the basics. And we're going to see how they kind of apply. So Python builds on that foundation with essentially 7 other ideas. Now, these can be grouped pretty easily. And when I say Python builds on that foundation, every computer language does exactly the same thing, just does it a little differently. So again, on my list here, you see variables, logic, and loops. Then the next two sort of group together, input. When you thumb your smartphone to, look at your cat pictures and check out your texts or whatever else you do on your smartphone, you're engaging in input. You're interacting with the computer. When I use my mouse, when I use the keyboard, there's all sorts of ways. Even voice now, I'm forever telling Google to turn off my vacuum cleaner. With all sorts of ways to input stuff into machines. And again, the output. When Google turns my vacuum cleaner off, that's actually a form of output. It did the thing I wanted to do successfully. The next three concepts, methods, functions, and objects, are all about the concept of reusable code. The thing about it is again, back to looping. Once you come up with a piece of code that does something you want it to do productively, you don't want to have to copy it constantly. You want to use it one time, but use it over and over and over again. And so all three of those concepts are related: methods, functions, and objects. And we'll touch on a little bit what they actually look like in a minute. Files. Okay, once you're done processing stuff, you want to store it somewhere, whether you're writing a letter in Word, whether it's a spreadsheet, whether it's a piece of music you recorded, whether it's a video, it's a file somewhere that needs to get stored. And then finally, errors. There are errors in everything, and capturing them and recovering from them gracefully and moving on without causing damage is an important concept. So let's dive into those a little bit in detail. Now, what I have here is essentially the definition of each of these concepts and a little tiny code snippet. So variables, what does that look like in Python? Very similar to other things. If you see here in green, I have x equals 5. X in this particular case is the variable. The variable is something you label, and that the programming language understands that that is related to some place in memory. In this particular case, we want to take the number 5 and put it in memory so we can do something with it. Second line says print x. Guess what? That prints the value in x. And we get, if we were to actually run this, the number 5. Okay, I'm going to keep blowing through these because, again, I want to make sure we cover them and give us plenty of time to chat about the program and other stuff. Logic statements, they compare values. Okay, we're always usually comparing two values. Now, you can have much more complicated logic, but at their core, it's always one thing. So at the top line here, var equals 7. Var is my variable. If the variable equals 8, then print the variable. But if it doesn't, print that doesn't work. It's that simple. You're making a choice based on the value of a particular thing. That value could be a number. That value could be a string or a set of words, a letter, a symbol. Any number of things could be stored in that variable. But the idea is choice. That if such and such condition exists, go do this. If not, go do something else. By layering those sorts of choices, you can come up with incredibly complicated and very useful things. Okay. Looping, again, going over something in order to have it, to save time and to save energy. So again, in this case, building on the concepts we had before, var equals 0 and limit equals 2. So we have a variable with a 0 stored in it, and we have a limiter with 2 stored in it. Now, again, these examples are meant to be simple so you understand the concepts. We're not building Google again here, but the idea here is all these things are just what you build upon in order to create, the next great app. So while var is less than or equal to limit, print, the value of var is var. And you can see my mouse cursor, that's what I'm reading here. So the print function has a string inside that's static, but the variable number changes. And the variable number starts at 0. And then here under this loop code, the var variable equals var plus 1. Once the logic gets down to here, the var variable is incremented by 1. So now 1 goes to the top, and this loops through. With var now equaling 1, then it's going to print the next number. Then it's going to print once it's adds this on the second try, 1 again, the limit is going to be 2, and then it'll skip printing it because the limit is now 2, and it will stop. So what we'll have is the output that I have here below. The value of var is 0, then 1, and then 2, and then it stops. That's what looping does. Input, very straightforward stuff. At its absolute basic, whoa, sorry. The top line there, very simple. In order to get input from a user at the most basic level possible, it's simply the input function. The word input with a couple of parentheses and an optional label that asks the user. So if we were actually running this code, it would print out, enter the starting number, and it would give us a flashing cursor that allows us to put something in. Again, we input values into all the computers we use every day in all sorts of ways that are much more complicated than that, but really at its core, that's exactly what we're always doing. When you make a choice, you click an icon on your tablet or your smartphone, that's what you're doing. When you click like I'm about to do here, on the right arrow, I'm just giving it some input. And again, the output. In this particular case, there's lots of different types of output. The most basic one is just simply printing something to the screen so we can see it. In this case, the print function is highlighted, and it's taking the value of the variable and printing it out to the screen. There's lots and lots of different outputs, audio outputs, video outputs. You know, if you're using a video game console, and a gamepad of some sort, you can have haptic feedback depending on what's happening in the video game. Lots of different output, well beyond just simple numbers and letters like we're dealing with here. I've grouped 6, 7, and 8 together. The idea of reusability is a big, big deal. Once you get into programming, you really realize why. And it can't be understated, and that's why there's 3 different concepts to sort of group them together. But again, once you've come up with a piece of code, you want to be able to encapsulate it and reuse it. So again, the idea here is that every computer language has a set of commands, functions, and methods that under the hood are actually collections of code that do something very specific. So in this case, we have input and print as examples of functions that perform specific tasks, but under the hood in Python, there's an interpreter that understands what those things do that's actually also built on Python. Files, again, very straightforward. Say you wanted to write or retrieve information from a file. In Python, it's very easy. We use the open function, these 2 parentheses, look for a file name, and the mode tends to be optional, but essentially opens what we call a pipe for the data to flow into memory at a particular variable name. And then finally, error handling. Code would not work without error handling because humans are fallible and we can't cover every possibility when we design a system. And so having, in this particular case, the try except system that's built into Python and other programming languages allows us to wrap code, and if something goes wrong, recover from it gracefully and either give an error message or simply move on to something else without crashing the computer. Now, I'm going to actually stop sharing because we've hit 7 o'clock and toss back to Corey, or at least ask Corey, or ask the audience if there are any questions at this point about the program or what we did there.
Yeah, we still have.
Go ahead, Corey.
We have time for questions, or if there was anything else that you wanted to go further into. It looks like there was one question about looping. Do we always have to put for I is what I'm seeing.
Yeah, I'm looking for the question. Where is it? Where is that?
From Greg Jones.
What time? What's the timestamp on that?
That would be 5:54.
Oh, put up there. 5. Oh, I think we're in different time zone.
Oh, sorry, 6:54. There you go.
Okay. Yeah. So yeah, the example I have there is interesting. Okay. Yeah. So do we have to always put for I? So there are two different kinds of loops in Python. Some programming languages have 3. Doesn't really matter. No, you don't have to use I. Okay. In examples, you often see I in a for loop situation. And let me switch back so that we all know what we're talking about here. So what is this? Greg? I think asked that.
Yes, I believe that was Greg. There's also another question in there from Russell.
Sure.
And a couple more questions coming in the bottom, so we can kind of take it one at a time.
Sure. Now, again, what I'm doing here is the example that you gave. Let me share my screen. Is slightly different than the one I gave here. Again, I used a while loop. There's 2 different kinds of loops, for and while. I did not give an example of a for loop, but the questioner is asking about that. There's 2 different situations. While a particular condition is what we call true being met, then you continue to do the thing, whatever that happens to be. It could be small or simple, or it can be complex. Doesn't really matter. While whatever's happening, do such a thing. An example of that, for example, might be some sort of countdown. For example, on your smart TV, you might have a dimming feature that if it's not being used for X amount of time, it dims the screen so that it uses less power and doesn't burn in the screen. And so as long as nobody's manipulated the TV, every time basically all these sorts of systems, whether it's my smartphone, all the computer that basically waiting to put a screensaver of some sort on, is always constantly making a countdown. And every time you touch the machine, that countdown is being reset to whatever limit you had already set. So for example, say you set your smart TV or your smartphone or whatever for 10 minutes before it locks itself or goes dim or something along those lines. While that happens, it's just going to sit there. And then, but once it gets to 0, it will then dim or lock or whatever the condition is, and then move on to something else. A for loop, and in the question that was presented, the idea of for I, the way I explain for loops is that there's a missing word. And what I wish for loops were actually called for every loop. And what does that mean? For every I inside of an object, do such and such a thing. Now, for coding examples, the audience member that posted that is basically saying, do you have to use I? Well, I is actually just a variable. That could be any label. And often I tend to use very descriptive labels for what I'm trying to pull from a data object. So say a data object has 10,000 whatevers in it that need to be examined. For every object or item, that's where I stands actually for index. Basically, each item stored in memory in a variable has an index value. That's essentially its address, and you can actually go to that address and pull that particular thing. But so for every index in a particular thing, do such and such a thing, and that's what a for loop is. Let me get off of this. That makes sense? Hopefully it did. Let's see. I'm going to go reverse order here because I'm kind of lost everything.
Let me know if you want any help.
Yeah, no, it's fine. Well, maybe I should go back to 654. Well, let me go back up to the top.
Looks like the next one was at 7:01.
Yeah, I'm just looking for others that I'll make sure I didn't miss anything. So lots of people have dropped their LinkedIn. That's great. And oh, by the way, feel free do look me up on LinkedIn and connect with me. And I'll be glad to make your acquaintance out there. Should there be product liability for code in a manner tantamount to what we see in pharmaceutical manufacturing? Excellent question. Way out of scope for what we could do here tonight. People have been arguing about that for a very, very long time. It's an awesome question. I'm getting the hint here, Russell, that you have some background. And hook up with me on LinkedIn, and I'd love to get to know you better. Send me a message. That'd be great. And yes, the same person that talked about the for loop, right? There are frameworks in code that people should use. The idea that systems that make coding either easier to use, more efficient, and that sort of thing. Would learning PowerShell scripting language help someone who is struggling with programming languages? I would say no. What I would suggest is that, so what is PowerShell? PowerShell is the Windows terminal environment where you can do scripting and other coding. What does that mean for those of you who have no idea what that is? Every computer, Macintoshes do a really good job about hiding all this stuff, but that's all available there too. Windows has a lovely interface and icons and all that stuff, but it doesn't take much to open up what we call a terminal in order to manipulate the machine and what we call the command line without icons and mouses and all that kind of stuff. So in Windows, PowerShell allows backend administrators to do scripting using the PowerShell environment that does not use Python. What I would suggest that the best thing to do is to focus. And I would really suggest, and I'm happy to share this with you, just look at the list of the 10 items that I presented earlier. And again, not to oversimplify, but really those are the basic concepts. And what I've noticed with my students is once they realize there's really a very, very small set of building blocks, and if you can focus down on the very tiny pieces of what you're trying to achieve in programming, it all gets clearer really, really fast. What's a good program if you want to get into law and cybersecurity? Gosh, there's so many and it's changing constantly. I don't have a recommendation that I could give you on that, but I would gladly talk to you about it if you want to hook up with me on LinkedIn and discuss the pluses and minuses of something. I love doing that sort of stuff. I think any sort of educational program is good or bad depending on what your goals are and what you're trying to achieve. So it sort of depends on what you're trying to do. Does Flatiron accept GI Bill or other veteran benefits? And also, will there be evening classes available for the next cohorts? As a general concept, I'm not in admissions. I'm not sure if Corey has more information that she could give right now. What I would suggest, if she doesn't, I do know that there are veterans benefits that can be used. The details of that, I don't know. I'm a veteran myself. So Nico, if you're a vet, awesome. Thank you for your service. What I would suggest is contacting the admissions office. And I'm sure Corey has more information on that than I do. And I'm sure they can answer that question.
I dropped a link in the chat just because
Excellent.
They typically know a little bit more. Those kind of things change on a regular basis just because of different regulations with the government. So scheduling a chat with the admissions, or if you want to attend one of our just general info sessions, we will have one on June 15th. So next Wednesday.
Perfect. And then as far as evening classes available for the next cohort, there's always a schedule on the website. And of course, the admissions office can set you up too. But the easiest thing is check out what's available in the coming months on the website. It's important to know that our program has different modalities of delivery, okay? Meaning that, for example, there's a live 15-week program where essentially you're working as though it's like an 8-hour-a-day job. And so that's very intense, but very short. And so there's pluses and minuses to that. That's usually scheduled between 9 and 6 p.m. Eastern time. I'm part of that along with my colleagues, and we do the live instruction and we support people throughout the day. As far as evening classes, those sorts of options are concerned, there aren't evening classes, but there are options you can do if a live daytime course online or in person just doesn't make sense for you. For example, our on-premises courses are in New York City and a couple of other locations across the country now, but a lot of stuff is provided online. We have what's called the Flex program that allows you to pick a time horizon that makes sense for your particular place in life right now. If, say, you need 20 weeks or 40 weeks or that sort of thing, the options are out there. Admissions can talk to you about the pluses and minuses of that. So to the extent that that could be sort of an evening type of thing, you're working during the day, but you need to work on stuff on the evenings and weekends, the Flex is probably what you want to look into and probably will fit the bill for you. Will the starting number always be provided to us? I'm not sure what that means. Mel, if you could repost if you're listening, I'd love to answer your question. I'm not sure what that meant.
Looks like they were talking about the part where you speak about variables.
Okay. On that particular question?
That was the next one I saw from Mel.
Oh, okay. I'm seeing a question about participating in the equipped program with SUNY Empire State. Do you know anything about that, Corey?
I sent them a link for the admissions as well because I don't know enough about that particular program. We do have a question in the Q&A. It says, do you recommend any other programming languages to learn for cybersecurity?
Yeah, no, is the short answer. And why? Especially if you've never, ever been involved. And I understand the idea of wanting to learn lots of stuff, but actually what we do is really focus on very specific things so that you have, in the time we have, you can not necessarily become an expert, but become very, very fluent in very specific things that employers want to see on resumes, okay? Employers don't want to necessarily see 2, 3, 5 languages. They just want to know you know the one, because once you know the one, you can do anything else, okay? And again, now, Flatiron has a couple of other programs that delve more deeply into hardcore programming. So if that's really what you're more interested in, you might want to just check out the pluses and minuses and weigh the difference between the two programs. But I would pick the one, and it would be Python because it's just simply the easiest thing to learn. It's the easiest thing to get off the ground on, and it's just ubiquitous. It's everywhere. So that's the thing. You'll run into lots of other languages, but Python has sort of become almost like English. It's just that widespread. So I would not try to figure out 2 different languages, because the thing is they're actually very similar. But what Python deliberately did was it looked at all the things that made programming less than human friendly, and deliberately attacked those things to smooth out the bumps and make it easy. And they're successful at it. So that's why you should stick with that for now.
It looks like Mel was trying to ask about the variable section again. They weren't sure if they understood it.
At this point, we're running a little bit on time, and I see there's a ton more questions. Why don't we do this, Mel? I'm actually going to drop my email in the chat, and name and email. anybody that wants to follow up with me on anything, please feel free to do so. And that's not just on Python, but any aspect of the course, because I teach all the topics and have a lot of knowledge outside of those topics as well. And I'm also very interested in developing the law side of things. So I got lots of information for you. But so feel free to email me there, and I'll be glad to get back to you.
See, there's a question about Python to create dashboards.
Can you use, sure. The fact of the matter is Python is both general and specific. What does that mean? Python is not, again, it's like a language, okay? It's just like spoken or written English or any other language. It allows us, just like English allows us to communicate virtually everything we need to communicate about anything. Python has all the tools necessary, the basic building blocks to create websites, to deal with databases, to do artificial intelligence, all the stuff you see in the headlines every day. So it's a general language, but it's also specific in that because over the last 20 years, people have used those building blocks to come up with very specific targeted libraries of pre-written code to do specific things. So for example, where Python has the input function and the print function and the open function, that's not an endless list. It's only about maybe 50 elements in the language that make up the core. All sorts of things have been built on top of that. And that is off-the-shelf code that you could literally go online and pull down and use for stuff. Everything from data mapping, GPS, artificial intelligence. If you can think of it, there's probably a library that someone has coded over time and other people have refined over time that you can tap into and use for a project that you want to do. I'm working in artificial intelligence projects myself here this summer, and I'm endlessly fascinated by all the stuff that people have already done. So yeah, creating dashboards like falling off a log, absolutely, sure. How many classroom hours is the CS course? Well, I'll tell you this, I know this. That's not the program that I'm in, but the 15-week full-time programs are all follow the same model in that if you were in cybersecurity, it would be the same as the CS course. What happens is that we have a day-to-day schedule that basically has 2 hours of lecture in the morning, 9 o'clock Eastern time, from 9 to 11. Then we have lab time. There's always an assignment that leads on from the lecture, and 2 hours of lab to work on the assignment, a lunch hour, and then from 2 to 4, a second lecture on another topic, and then from 4 to 6 is a lab that leads on from that. So, and every day is like that for the most part. Sometimes, you know, we just had Memorial Day, we had to move some things around. What that allows us to do is to target very specific topics without overwhelming you too fast. And what that does is it allows everybody to move together while building one block at a time and accumulating a lot of information. In any given 3-week period, what we call a phase, there are 5 phases in the 15 weeks. In a given week, you'll have 10 lectures across 5 different subjects. We always only have 5, there's 8 total subjects. They're kind of spread out across the 15 weeks. But so if you look at 10 lectures times 2 hours, you're spending 20 hours a week. Did I have that right? 5 times 4, 20, right. So, right, you're having 20 hours of lecture and 20 hours of lab every week. but because of the way we have the schedule set up, most of the time the assignments are not necessarily easy to do, but you can usually get them done, if not within the 2-hour lab period, certainly within the evening or the next day, so that you can stay on target. Is this program geared more toward folks who are newer to tech and program? Absolutely. You know, if you see boot camp in the title, definitely that's an indicator that this is not for people who have a deep knowledge already in the industry. Boot camp, just like military boot camp, any of the veterans on the call here, like myself, that have actually been through real boot camp, it's the same sort of idea. If you went to real military boot camp, you might go to Navy boot camp or whatever for 8 weeks or so. Then you graduate. You know, at that point, are you a professional sailor? Absolutely not. You know some basic rules. You know how to fold your uniform. You know how to walk in a straight line and a bunch of other stuff. But really, you know, you're just getting started. Most military members then go on to specialized training in very specific things. It's the same thing with boot camps here or in any other programs that consider them boot camp style. The idea is a very targeted, very specific set of information that gives you a solid foundation, that gives you an entry into an employment situation where employers know that you're not meant to be an expert, but they're going to give you the experience and training you need to do the very specific thing that needs to get done. You're welcome. I appreciate the appreciation. Thank you.
Trying to see if we have any more questions as we wrap up. Any last minute questions, y'all? I did drop in a link to our admissions info session. That's going to be next Wednesday for anybody with more general questions. If you don't want to schedule a chat, that's another way to go and learn a little bit more detail about all of our programs.
Thank you, Grace. I'm glad you found this session helpful. Here, let me drop a couple of links myself in. They're at the top, but so they don't get lost. Was hoping we would have time to dive into this, but we're running out of time. If you want to get started on your own, it's actually really easy to do. You want to go to https://www, probably not a surprise, python.org. Okay, that is the home of Python on the internet, and everything. If you go to their homepage, you should see beginner, intermediate, and advanced. And if you dive into the beginner section, you can teach yourself this stuff. It's certainly great to have students, and there's a lot of value to that. But you can certainly dive into this and get your feet wet. To help you do that, you need a tool. You don't absolutely need a tool, but it's helpful. And MIT developed for this purpose a integrated development environment, what we call an IDE, called Thani. And it's thani.org. And if you go to thani.org, you will, let me just share my screen real quick on that because I do have it up. All right. So over here, if you can see this, this is the Thani homepage at thani.org. And if you look here, you can download for Windows or Mac this piece of software. It's a very small download. It'll come down really fast. It's a really quick install, and you can start playing with software really, really quickly. And so this tool that allows you to do that, along with, and this is what it looks like when it's actually running. So for example, I have just a very simple program here. If I can grab it, there we go. And if I run it, I got an error. Sorry. Well, anyway, this is what Thani looks like. We're running out of time, so I'm kind of going too fast. But the point is that go to python.org, go to Thani, download that piece of software, And you'll find all sorts of examples, endless examples, really, and incredible documentation, and all sorts of tutorials at python.org. And if you have, basically any basic computer skill, basically to use a keyboard and a mouse, you can probably get yourself off the ground. So you're welcome. It's really gratifying to see all these thank yous here in the chat. You're all very, very welcome. And again, I'm gonna post my email address just in case as it gets lost. Absolutely, everybody hook up with me on LinkedIn, and feel free to email me as well. And if I don't have an answer for you, I will make sure I get you one. Excellent. Thanks, Enrique. Where do you work in law enforcement?
Ooh.
Bronx, awesome. Is there a certain laptop I should be using for the cybersecurity course? A cheap one is the short answer. Most of what you're going to do is in virtual environments out on the web. Okay. Most of the stuff doesn't require any processing power at all. The way I say it to people, if you can do your web banking and watch cat videos, you're going to be fine. The one thing you might want to do is just make sure you have a decent amount of memory. 16 gigabytes is a good start. The reason you do that is if you start using virtual machines, meaning spinning up virtual computers within one piece of hardware so that you can play with how they talk to each other, attack each other, pen test, you can do all that stuff. And so the more memory you have, the more virtual machines you can use. And if you are running Windows, you want to make sure you have a good 8 gigabytes just for Windows itself, and then anything beyond that reserved for virtual machines. So, but yeah, you do not need a workhorse power machine to get through this program. If you're probably sitting on your laptop right now looking at this, you're probably just fine. We do have more detail on that on the website. And again, I can get you more than that if you want to email me. So yeah, that's actually a good point. Greg posted to everyone there the website called Programmers. I've seen that one before. It's an online compiler. That's probably a little bit more advanced than what most people need. Can you practice with just a smartphone? I'm not a big texter. Okay. Okay. So, I text with my daughter a lot. So I cannot possibly imagine programming with my thumbs. Okay. So I think you could probably read a lot on a smartphone, which I do constantly, and feed your brain. But I'm pretty sure if you're going to do any serious programming, you're going to need a keyboard. All right.
Okay, well, as we wrap up, thank you again to Joseph and everyone who zoomed in to join us tonight. If you have any further questions about Flatiron School, I am dropping some links in the chat. That is going to be our YouTube channel where we post all of our events after we send them out to you. So this recording will go out within 3 business days along with any event materials we used. And then there's also that admissions chat in there again, if you want to set up a 10-minute chat with them. As a reminder, you're going to receive that presentation within 3 business days. And if you want to see any of the previous events or this event after you get the email, it's going to be on our YouTube channel. So thank you, everyone, and have an amazing night. Bye, y'all.